Hello, my friend. Thank you to participate to this training. So we're going during this class to talk about flood risk assessment. So we're going to develop a methodology, a standard operation procedure, SOP, to learn how to use open source software such as Hec-RAs, Hec-Hms, and QGIS to develop a flood risk assessment. Thank you guys, and let's go. I also want to add, guys, that I have a lot of experience. I work for many governmental agencies in research. I presently live in Canada, so I work at some university research center too. Actually, I'm a managing director of a company called GeoRisk Environmental Solution. We conduct and produce a lot of consulting in environmental science, in environmental project, and also in data science. So guys, welcome again, and let's start our training. Okay, my friend. So what we're gonna do, we're gonna go to this website to download the open source software. So these are three software we're going to use: QGIS, Hec-RAs, and Hec-Hms. This is open source software. We're going to use it. And after we download this software, we're going to learn how to use this software. To learn how to do watershed and streamline delineation, how we can see it here. You guys are going to learn how to do this: streamline delineation, watershed, and also how to do perimeter delineation. We go to do the perimeter delineation here, how we can see it here with RAS mapper in Hec-RAs. This is what you guys are going to learn how to do it. For all our stream, we're going to learn to do it. And next step we're going to do, you guys are going to learn how to do refining region. Like you use a different kind of cell, big cell and small cell, because the calculation can be very long. So you're going to learn how to do some refining region. After you're going to learn where to go to download the data. There's a lot of websites. I'm going to show you a few where you guys are going to download data to do some land cover data, or what kind of data you can go for all the map, all the road. You can go there to download some data for our GIS, Geographical Information System. After we're going to learn what is the Manning's value, roughness coefficient, we're going to teach you what is it, how you can use the roughness coefficient, the Manning S value in our calculation. So you have some website, or you can see, depending on the terrain property, we have a different kinds of Manning value. This is important to know. And we're going to do some rain on grid. You're going to see how the rain, we can do some modeling of the rain, and the rain we're going to propagate in our terrain. We're going to learn how to do it, rain on grid, and here also going to build a different kind of geometry. And after we're going to learn how to do some dam, channel bypass, and building, and more terrain modification. We're going to learn how to do this. You can use some dam, some channel bypass, and how to add some building, some more modeling in the terrain. As you can see it here, the water is going to exit here, and we build a project here, how we can see water going to flood, a lot of flooding here, water going to go in the channel here. You can see it here. So you're going to do it here in your terrain, or you can create a model, you can create a channel, and doing the flooding where the water can exit, where the water can go. So it's very important here, as you can see it here. And after we do this, more thing important also to do, we're going to learn how to do some bridge, and also how to do some dam. Let's say, for example, here we want to add some dam. I'm going to teach you how you can add a dam here. And if we have a dam here, you guys can see the dam, we're going to stop the water coming. So this is all these kind of things you guys are going to learn in this project. So you see the dam I build here. I build the dam, and if I build the dam, I can build also a different kind of thing, channel. I can build a bypass here. We're going to learn how to do some dam, how to do some bypass. And also we can add some geometry, like some house, some building, and we're going to know to check how the water going to impact. Is the building going to be flooded? Let's see, for example, when we build the dam, we put the dam here, you can see the water coming, And the dam going to stop the water to propagate, as you can see it here. The dam is going to stop the water, water won't propagate in our field, and it's going to build. And also, when you can see it here, the house, depending of what kind of coefficient, what kind of roughness, or manning, and what kind of altitude of the building won't be flooded until the water build up and the water start to inundate the building. You can see it here, the building are going to be flooded depending on the height of the building. If the building is not very high, it will be flooded, but if the building is very high, it will be stopped. And you can see the channel here. The channel also going to, the bypass channel, going to use it. We're going to use it to propagate the water in our project. As you can see, guys, it's very interesting stuff you guys are going to learn, you guys are going to build in this project. As you can see, the water going to simulate, and you can see the water here at the end of the simulation where all these kind of things going, all the water is already propagated and it's moving in our model. So we have also a 3D view, or you guys can see and learn to do how to visualize in the 3D model. Or you can see this is our terrain in 3D, and you can see the water is going to propagate in our terrain. It's just a 3D view. Very interesting to see, to have a different perspective of our terrain, of our simulation. So you guys can see, like you can see the dam we put, and we can see the water we propagate, the dam going to block the water, and after all the channel and all the bypass going to be used, and the water is going to circulate in our model. This is all this kind of thing, interesting thing you guys have to come to do during this training. And you guys to learn how to do all this kind of thing, all this simulation in 3D also. And yeah, and finally, the final project is going to use a coastal big wave modeling. We're going to model a tsunami. If there's a big wave, a big tsunami coming, we're going to learn how to do this modeling. We're going to model the tsunami coming in our coast. So there is an interesting thing you're going to know. We're going to do some parameter. We're going to try to choose the big parameter. Look at the wave. We do the simulation. And the big wave is going to propagate in our terrain, our city. We're going to know where the water is going, which city is going to be affected by the tsunami, which area are going to be flooded. This is all this kind of stuff you guys are going to learn in our project. You can see the big wave coming from the water, from the coast or the ocean. It can be a tsunami, it can be a very big wave, and it's going to flood our area, and this area going to be affected by the flooding. You can see after the end of the simulation, the water going to retract. I can show you again slowly, and you can see the water is coming at the beginning of the wave, and after just propagate here. You see the water here just continue to propagate in our terrain, in our coastal city. So you guys need to learn how to do this and to see which area will be very flooded, and you know where you can buy house, where is very safe, and if you know how to put the dam too, you can know how to mitigate this situation. So finally, this is a 3D view of our last project we did, and you can see like the water coming, and you can see the view here, the 3D view, where the water going to invade, going to circulate in our terrain, in our 3D terrain. Guys, this is the course you guys are going to do. You're going to learn a lot of things in this course. This course is very interesting. So thank you for coming here, and don't forget to do all this by yourself. Just learn. It's very interesting. Try to learn by yourself, and all these techniques you're going to learn how to do this flooding, risk assessment, all this kind of things, all this calculation, all this technique we're going to use. Try to do all this step by yourself, so you're going to know how to do the Reynolds grade, how to do the flow hydrograph, how to do the stage hydrograph, how to use to learn Hec-RAs, how to use to do the watershed streamline. So thank you guys, and see you soon in our project.